Hello, this is Mr. Stein, and in this video we are going to look at the Chapter 6 unit in graphs. We're going to look at this function right here. Y is equal to 2 to the power of x. Now, if you remember, we could write this in function notation. Our function on x is equal to 2 to the power of x. Our variable is in the exponent. So what we have to do, we have to figure out our table of values here. We have our table of values. We're going to put this -3 in. And that is going to give us 2 to the power of -3. Now 2 to the power of -3, if you'll remember, is 1 over 2 to the power of 3, which is 1 over 8. It's our fraction 1 over 8. Okay, now we don't want to write out so many steps this time. So for -2, it's 2 to the power of -2, which is equal to 1 over 2 squared, which is 1 over 4. Now we put -1 in. 2 to the power of -1 is just equal to 1 over 2. So it's 1/2. So these are the values that go in our table of values. That's what we'll be graphing. We put 0 in. 2 to the power of 0 is equal to 1. We put 1 in. 2 to the power of 1 is equal to 2. 2 in. 2 squared is equal to 4. 2 cubed is equal to 8. And 2 to the power of 4 is equal to 16. There's our table of values. 1/8, 1/4, 1/2, 1, 1, 1, 2, 4, 8, 16. All right, now we need to graph it on this. I'm going to stretch out my x-axis a little bit because, well, I've only got 4 things, so I'm going to stretch it out. I'm going to use 3 of them. That's 1, 2, 3, 4, 5. We don't need to go to 5. -1, -2, -3, -4. All right, now we have to go all the way up to 16 here. So we're actually going to have to go up by 1s each time. But I'm not going to write down every number. I'm going to write down every 5th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And there's 16. That's the highest I need to go with these. All right, so let's graph this. At -3, it's 1/8. So at -3, it's 1/8. That is going to be like right about there. At -2, it's 1/4. That is going to be, I'm zooming way in here. That's going to be about there. At -1, it's 1/2. That's going to be about there. At 1, it's going to be at 1. At 0, it's going to be at 1. At 1, it's going to be at 2. At 2, it's going to be at 4. At 3, it is going to be at 8. At 4, it's going to be at 16. That's right there. That is what this graph looks like. This is called an exponential graph. And exponential growth is a phenomenon that happens quite often. Population often goes by an exponential growth. Virus spread is often exponential. But there we have it. Did we need the negative numbers? No. Now, look at how this graph is going down, down, down. Do you think it's ever going to get to this line? Do you think it's ever going to get to this line right here? Well, let's take a quick look. And let's go on. At 1/3, it's at 1/8, right? 1/4 would be at 1 over 16. At -5, it would be at 1 over 32. At -6 would be at 1 over 64. These keep getting closer and closer to 0, but this graph never touches y equals 0. Never gets to y equals 0. All right, let's write the domain and range. The domain. So that the domain is how far left and right this graph can go. This graph can keep going left and right forever. We can put any number in it. So our domain is all the values of x such that x could be any real number. We can put any number into this function. That was a terrible squiggly brace there. My goodness. That's a nicer one. Our range. Our range is how high up and down this graph goes. Well, this graph is in this positive area here. The graph's in the positive area. The graph is never down here in the negative area. And the graph will never be exactly at 0. So it's all of our y values such that y is bigger than 0. So our range is all of our y values such that y is greater than 0, strictly greater than 0. And y can be any real number that's greater than 0. So there's our domain and range. All right, I hope this was helpful to you. I hope it reminded you of some things from last unit. If you have any questions or comments, please put them in the comments below.